This is going to be a very quick video all about the cause and effect and changes in Earth's system. So one thing I do want to talk about first is the positive feedback loop. This is that cause and effect loop that keeps building on itself, because positive in this case does not necessarily mean good. It just means it's adding on to itself. So this picture here, we have the sun and it shines on ice caps as well as open water. When it hits the ice caps, it reflects a lot of the sunlight, and when it hits the open water, it absorbs a lot of sunlight. Absorbing is going to increase heat, reflecting is going to bounce the sun away, therefore heat can't be absorbed by the earth. So the positive feedback loop that's happening is because of global warming and climate change, temperatures are rising. When temperatures rise, the sea ice melts, which means more of that dark water is exposed, means more sunlight is absorbed, which means temperatures are going to rise because we absorbed more heat, which means more sea ice is going to melt and more dark water is going to be exposed. And you can see how this kind of just builds and builds on itself, getting more and more over time. So that is a positive feedback loop, the idea that it just keeps building and building, getting more and more, not necessarily getting better. There we go. Another part of this is the albedo effect. Albedo is just like a fancy word that talks about reflectivity. It's on a scale of like 0 to 1 or like 0 to 100%. So when you see it on the test, think about just replacing the word albedo with reflectivity. Something with more albedo is more reflective. These are light-colored things. They're going to reflect more light and usually lead to cooler temperatures. Remember our video we saw in class of Daisy World? The white-colored flowers will reflect more light, whereas the dark daisies will absorb the light. So less albedo would be dark colors. They absorb more light, therefore usually leading to warmer temperatures as well. So just super quick on what albedo is. It is in one of your passages on the quiz. I just want to give you that quick review and just to have it super clear and straightforward. Come on, there it goes. The other part of your quiz is all about the wetlands. You have a few passages to read in there, but I want to talk about this graph because this graph is a little bit funky and I want to make sure that it's super clear to everyone. So this graph is about reduction of pollutants due to wetlands. And I know these blues are different colors, but the light blue does actually mean the channelized wetland, and the green is functioning wetland. Functioning wetland, that would be a natural wetland. So as if you've never touched it, left it alone, that is a very stationary wetland. A lot of water just kind of sits for a long time. The blue is channelized wetlands. These are man-made, where people have either tried to create a wetland by like digging a hole, or they try to like dig like a side stream next to a main body of water where excess water can get to. I think part of this could be like those ditches you might see in front of your houses. Might be a type of channelized wetland. Um, but the water will flow a lot faster through the channelized wetland, whereas like a natural wetland is very stationary. It kind of stays still and the water in there stays still for a long amount of time, usually only kind of leaving the wetland when there is less water outside of it, or by evaporation. It pretty much will stay there, or if the groundwater starts to like let it seep through slowly. So this graph is showing the comparison between the functioning wetlands and the channelized wetlands. On the y-axis here, we have the percent reduction. Notice that 0 is a choice. We could have nothing happening to the reduction of these different types of pollutants. So E. coli is like a super bad germ. Sediments would be like sand and things of that sort. These are nitrates, nitrogen, phosphorus, and phosphates over here. And we want to have a higher number of reduction. The more it is reduced, the cleaner the water becomes. So for example, the E. coli has like a 70% reduction, whereas a channelized wetland is only about a 30% reduction. For sediments, that 80% reduction, whereas with a channelized wetland, it actually adds sediment to the environment. So these negative numbers would mean it's not getting rid of it, it's actually making it worse. So we have more sediment being added from the channelized wetlands compared to giving it time to settle with a natural wetland. Same thing with nitrates, more is added with channelized wetlands, whereas a lot is reduced with functioning wetlands. And pretty much in every category, we see functioning wetlands do better than the man-made wetlands. The man-made wetlands may be better in a few other ways. Usually they are smaller, probably easier to maintain, don't take up this much space, relatively easy to install because you just gotta kind of dig a hole. But in these categories of reducing these types of pollutants, the functioning wetland is superior to the channelized wetland. All right, if you have any other questions,